Way 49 deals with stable electron configurations. If you recall, every atom bonds with another atom to achieve a stable electron configuration. And what does that look like? Well, what it looks like is having a filled valence shell. And the only group in the periodic table that features that is group 18. Notice that helium, neon, argon, krypton, xenon, radon, they all have a filled outer shell. Note that in energy, the first energy level, which is represented by this first digit, the maximum you can fit is 2. But beyond that, every atom is happy when it has 8 valence electrons. We call that a stable octet. For that reason, group 18 tends to remain generally unreactive. They don't tend to react with other atoms and therefore are chemically inactive, or what's called inert. So when it comes to problems like these, note that anything that has 8 valence electrons is considered stable, and anything that does not have 8 valence electrons will try to bond with other atoms so that they can achieve 8 valence electrons. So let's try some problems. Elements that have atoms with stable valence electrons in the ground state are you said choice 4, you were paying attention. Group 18 has stable valence electrons because they already have 8 in their outer shell with the exception of helium. Explain in terms of atomic structure why group 18 elements on the periodic table rarely form compounds. So again, you have to mention something about their structure or the components of their structure, which explains why group 18 rarely form compounds. You would simply have to state that the valence electrons of atoms of group 18 elements already have stable electron configurations. They already have an octet, or 8 valence electrons, with the exception of helium. Thus, they rarely react to form compounds. Notice that I mentioned their valence electrons and that they have already a stable electron configuration. In order to get full credit, you have to mention something about their atomic structure, something about their makeup. And I stated that when I said valence electrons or stable electron configuration. Which statement explains why neon is a group 18 element? Remember that elements and atoms are grouped on the periodic table so that elements that are in the same group are chemically similar. Thus, neon tends to be in group 18 primarily because it has a stable valence electron configuration. It already has 8 in its outer shell and is therefore stable and happy. Which group on the periodic table has elements with atoms that tend not to bond with atoms of other elements? Hopefully you're sensing a pattern and correctly chose 4 as your answer. Why? Because group 18 already has 8 valence electrons and a filled outer shell, and therefore does not react with other atoms. In the ground state, which atom has a completely filled valence electron shell? Anything from group 18 will get this answer correct, and you should have chosen 3 as your answer. In which group on the periodic table would a nonmetallic element belong if atoms of this element tend to gain 2 electrons to complete their valence shell? Here we're looking for a nonmetallic element that tends to gain 2 electrons to complete their valence shell. If you'll notice, the only group that requires 2 more electrons are those that have 6 in their outer shell. Which group does that belong to? That belongs to group 16. Notice that the last digit of every element in group 16 has 6 as their valence electron number. What do they want to be stable? They want 8. So therefore will gain 2 electrons in order to complete their valence shell. Which ion in the ground state has the same electron configuration as an atom of argon in the ground state? So remember, group 18 are happy, stable atoms. They already have a filled outer shell. So elements will try to bond with other atoms such that they achieve the same electron configuration as that of group 18. So this one is asking which of these ions has the same electron configuration as argon? Well, if you look at argon's electron configuration, it's 2-8-8. So which of these ions in the answer choices has the same as 2-8-8? Note that potassium already has 2-8-8-1. You should be looking for elements around or close to argon. So look at the period where argon is and the period right after, because potassium, which already has 2-8-8-1, will much more easily lose that last electron in order to achieve the same electron configuration as argon. Once it does that, it loses that negative electron and becomes positive. So the answer is 3. Potassium ion will have an electron configuration of 2-8-8 because it's lost that negative electron and is positive. So when it comes to way 49, note that group 18 is generally unreactive or inert. Why? Because it already has filled outer shell electron, a stable electron configuration. All the atoms are trying to get there, so they'll react with other atoms and bond with them such that they gain that stable electron configuration of 8 valence electrons. Hopefully this was helpful, and thank you for watching.